We are going to continue to basic integration formulas. This time we have the trigonometric integration. If you remember the cosine x derivative, it was equal to minus sine x. So the integral of minus sine x, or it should be cosine x. So integral of sine x only, it's equal to minus cosine x plus c it must be. So I explain again with derivative how the formula it's going to be. And we need to, of course, learn them by heart, these formulas. Integral sine x minus cosine, like in derivative, opposite, both of them. Integral of cosine, it's going to be sine x plus c. This time the integral of sine is negative, integral of cosine is positive. Here the second formula and the fourth formula, sine ax plus dx plus b dx it is. And the difference between these two formulas, normally what is written here same, ax plus b, but we have the coefficient here as a coefficient of the insider function written in front of the cosine and 1 over a form. We are going to divide, because in derivative we were multiplying with the coefficient. Here we are going to divide by the coefficient. Okay. Here the same formula, cosine ax plus b. Normally if it is cosine x dx, sine x plus c it was. But if it is cosine ax plus b dx, it should be 1 over a. The coefficient comes as a 1 over form. 1 over cosine square, it was equal to secant square, and that's equal to 1 plus tangent square. If you remember the 1 plus tangent square, the derivative of it was tangent. Tangent x derivative, what it was equal to 1 plus tangent square. So the integral of 1 plus tangent square, it must be tangent. What about ax plus b, tangent square ax plus b? X plus b, what it's going to be? 1 over a here. If it is 1 plus cotangent square, it's minus cotangent x. And 1 plus cotangent square ax plus b, if it is, we are going to have here minus 1 over cotangent ax plus b. Here maybe these are going to be new for us. Integral 1 over square root of 1 minus x squared dx. This is the here integral of the inverse trigonometric function. If it is square root of 1 over 1 minus x squared arcsine, it is. If it is integral of 1 over 1 plus x squared, that's arctangent is going to be. And as you see, arcsine and arccosine, the derivatives, the integrals, it is same. Actually, the arccosine derivative and arcsine derivative, with respect to sine only, there was a difference. But they were same. Okay. Here are the questions. I said the coefficient of sine is not going to affect, so integral 4 times sine x plus c, it must be this one, sine x plus sine x dx is going to be 4 times. Now we are going to get the integral of these trigonometric expressions. Integral here, this the coefficient of sine, that's why you may write down in front of the integral, but you cannot write this 7 in front of the integral. And here it's equal to 4 times sine x dx. If you remember in the previous page, I explained this is going to be integral minus 4 times cosine minus 4 times cosine x plus c is going to be. Okay. What about sine 3x? This time the coefficient, it's in front of the x, that's why it's going to be equal to minus cosine. Actually 1 over 3 times is equal to minus 1 over 3 times cosine 3x plus c, it must be. What about cosine 7x plus 3? It's equal to sine 1 over 7, the formula with 1 over 7, it is 1 over 7 sine 7x plus 3 plus c, it must be. Okay, 5 sine 2x minus 1. 5 times integral sine 2x minus 1, it's going to be dx. I got the here I got the dx pardon, I got the 5 out. On this page we are going to solve these questions. Here integral of 5 we have here. So 5, this is the coefficient of sine. You may get it out of the integral sign, so it's equal to sine 2x minus 1. This is the ax plus b form, so it's going to be equal to 5 times 1 over 2. This is ax plus b. B is equal to minus 1 here. 1 over 2 times, actually we have the minus sign here also, minus. So cosine 2x minus 1 plus c it must be. So the answer is minus 5 over 2 cosine 2x minus 1 plus c is going to be. Here cosecant square we have. Cosecant square, if you remember, it was equal to 1 plus tangent square x. 1 plus tangent x squared dx, it's going to be tangent x squared, not tangent x squared. Tangent square 3x dx it should be. If we have 1 plus tangent square, it means that the integral is equal to tangent 3x. I didn't write the coefficient here. Tangent 3x we are writing firstly, then the coefficient is written as 1 over 3 plus c, it must be 1 over 3 tangent 3x plus c is going to be. Okay, the next one, cosecant square. This time this is 1 over sine square x. So the integral 1 over sine square dx, it should be equal to integral, not sine square, of course, this is sine square. This is integral 1 over sine square 5x minus 3. 5x minus 3 dx, it's going to be, that's equal to 1 over sine square, it's going to be equal to 1 plus cotangent square 5x minus 3 dx. This part is trigonometric substitution. Now we can continue to our integral operation. 1 plus cotangent square ax plus b, it was equal to minus 1 over a, which is equal to minus 1 over 5 here. Cotangent 5x minus 3 is going to be. Okay, cosine square dx we have here. For this kind of questions, what we are going to do, because this is not like cosine, this is not like this is not like cotangent square, or this is not like here cosecant square. So the integral of this type of questions, we should make some trigonometric substitutions. With respect to that trigonometric substitutions, we are going to solve these questions. The trigonometric substitution that we need to apply here is going to be here. If you remember, the cosine square x, it was equal to cosine 2x plus 1 over 2 it was. Why am I applying this trigonometric substitution? Because we don't have any formula with cosine square x. So instead of cosine square x, if I write cosine 2x, I will find the solution of the question. So it's going to be like this. Integral cosine square x dx, it's going to be equal to integral cosine 2x plus 1 over 2 dx, it's going to be, that's equal to 1 over 2 integral, 1 over 2 cosine 2x plus 1 over 2, it's going to be, I separate this 2 to cosine 2x and 1 over 2 as 1 over 2 integral dx, it's going to be, if we close the parenthesis. Okay, the integral of 1 over 2, I said the coefficients are not important. That's why I got the outside cosine 2x. It's going to be, and this is going to be 1 over 2 here, 1 over 2 integral dx. It's going to be integral dx. We know that's equal to x plus c, and cosine 2x is equal to 1 over 2 times 1 over 2 times sine 2x plus x plus c is going to be, okay, then it's equal to 1 over 4 times sine 2x plus x plus c. It must be here. This is the second question, but we are not going to do trigonometric substitution here. We have the formula like 1 plus cotangent square. 1 plus cotangent square, I need x. But if I write here 1, I need to subtract this one again, and it's going to be equal to 1 plus and minus 1. Then it's equal to dx, and I'm going to separate like this: 1 plus cotangent square x dx, and integral minus integral dx. It's going to be minus 1 times dx. It's going to be. So the integral of dx, we know that it's equal to x plus c. Integral of 1 plus cotangent square is equal to minus cotangent x plus c. It's going to be, but common c that is here. So the answer of the question, it should be like this. For this type of questions, we are going to apply the trigonometric substitution again. Here I remember cosine square alpha minus sine square alpha. Both of them, they are cosine square 3x and minus sine square 3x. And I know that I can get the integrals for addition and subtraction together. Cosine square 3x minus sine square 3x can be also dx. It can be written like this. And cosine square alpha minus sine square alpha, I remember that is equal to cosine 2 alpha. So cosine 2 alpha, yes. So this is going to be here, it's going to be equal to integral cosine 2 times 3x dx, integral cosine 6x dx. It's going to be, and integral of cosine, it's going to be minus sine and 1 over 6, the coefficient of the x, minus 1 over 6 sine 6x plus c is going to be the answer. It seems maybe at the beginning difficult because cosine square 3x, it's going to be equal to 1 plus 2x over, if you remember from the previous page. So it will be long, but if you remember the formula here, also I solved this one, and in the exam you will remember. That's why we may solve this kind of questions.